All right, moving on to the 1.9 notes, multiplying binomials. After this lesson, you should be able to multiply polynomials in the form of sum and difference binomials, and also multiply polynomials in the form of squaring binomials. Okay, so I'm going to skip on down to example 1, where we are asked to multiply two sets of binomials. All right, so let me give you some time to go ahead and do that. Make sure, again, you're showing all your work, and we'll check back and see how you did with these 3 examples. All right, so let's see how you did. Okay, so as you can see, the work here to get our answers for these, again, we're going to use that form of distributive property, or some of you mentioned to me that you're knowledgeable of the concept of FOIL, which again is just an organized version of the distributive property. All right, but either case, you should end up with what I have here on my notes. Now, you're going to notice that what happened to all 3 of these examples is that after we did the distributive property or the foiling method, that a couple of the terms that came up were opposite of each other, to the point that when you combine those like terms, the x term was specifically disappeared, It ended up to have a sum of 0, so it was not part of our final answer. All right, so now that particular situation happened because of the way that these problems were set up. Okay, so let's look more closely at that setup. Now, again, we notice that we are multiplying 2 binomial expressions. What is also true about these 2 binomial expressions is that they have the same terms inside the parentheses, Here we have a 3x and we have a 2, 10x and a 3, x and 4, the same 2 terms in each binomial. And we should also notice that the signs in between each of those binomials are a plus and a minus. Okay, so that's a pattern in how these problems are set up. And it's in that pattern that we want to be able to find a shortcut and more efficiently find the product of these type of problems. Okay, so again, these problems are called sum and difference binomials. So again, the setup is that we are multiplying 2 binomials that have the same 2 terms in between, or inside. And in between those terms, we always have opposite signs, 1 plus and 1 minus. Okay. So here's your little shortcut. And we're going to notice that the 2 terms that are in our answer are simply the terms in the problem squared. We're also going to notice that in our final answer, the sign is always a minus. Okay, so let's go ahead and apply this back to the original 3 problems. So I'm going to erase my work here. Keep the answer. And we're going to go and apply this shortcut. Again, recognizing that is a sum and difference binomial. Same 2 terms inside the parentheses with opposite signs in between. According to this, to get our answer, all we need to do is to take that one of the terms, square it, take the other term, square it, and put a minus sign in between. X squared is x squared, 4 squared is 16, and there's our minus sign in between. Part B, applying this pattern right here, We're going to take the first term of the binomial, put it in parentheses and square it. Take the second term of the binomial, put it in parentheses and square it, and put a minus sign in between. 3x squared, that's 3x times 3x is 9x squared. 2 squared is 4 with a minus sign in between. First term of the binomial, 10x. Got to square it. Last term of the binomial, or second term of the binomial, 3, square it. Minus sign in between. Okay, so that's how you can use this pattern, right? This recognition of a pattern to kind of shortcut your work just a little bit, right? And always, you need to make sure you're showing your work on homework, quizzes, and tests. Okay, so now the next part of the notes goes through some examples of an experience of squaring binomials. All right, so here we have a table again, like from the last lesson, and we are trying to examine the x plus 7 quantity squared. And this is us squaring a binomial. And we want to try to figure out, of the 3 expressions that follow, which of these expressions is equivalent to the original. Okay, so I want you to go ahead and just do the top row, right, where x equals 1. So again, as the last lesson, you're going to sub that in for x for each of these 4 expressions and see which ones are the ones that are equivalent to the x plus 7 parentheses squared. All right, so as you saw, right, the only expression that gave us an equivalent value to the original is this one. All right, so these two are equivalent. All right, so this is going to kind of prove to you, hopefully you can remember this, all right, that when you square anything, right, here we're squaring x plus 7. Squaring means we're going to multiply that base times itself. So here we're doing that same thing that the original expression is saying, is we're going to take x plus 7 and multiply it times itself twice. All right. This one right here is going to disprove a common mistake or idea that people believe is true. Right. The common mistake here is that when we're squaring a binomial like this, is where students would, quote unquote, distribute that exponent through the parentheses, right? If you imagine, if I took this 2 and distributed to the x, I get x squared. If I take this 2 as an exponent, distribute it to 7, I get 49, right? And then I just transfer that plus sign in between. All right, so this right here, this example proves to you that that does not work. These are not equivalent expressions, okay? The only way that you want to interpret how to evaluate squaring a binomial is like this. Okay. All right, so moving down to the bottom half of the note sheet here, it says we want to use a distributive property to show that parentheses x plus 7 squared is equal to x squared plus 14x plus 49. All right, so again, as we talked about, right, we're going to take the binomial that we're squaring and we're going to multiply it times itself. All right, so if we go through now, we got to be careful here, right? This is not that sum difference situation that we talked about in the beginning of the lesson, right? I'm not just going to take the first term, square it, take the last term, square it, and put a minus sign in between. All right, again, the big difference here is that the signs in between are the same. While we do have the same terms for our binomials, the signs in between are exactly the same. So this is not a sum difference binomial situation. Okay, so we're going to go through the entire process of distributive property or FOIL. So I get x squared plus 7x plus 7x plus 49. All right. I'm going to go and combine these two like terms here in the middle, and I get x squared plus 14x plus 49. Okay. So that's going to bring us to the part of this conversation where there is a shortcut if we observe our situation properly, and where we can maybe save ourselves a couple steps in this process. All right, so what you're going to notice here is that these two terms here in the middle are exactly the same. Right? These two terms are made up of the product of the terms that are in the original binomials. Okay, so we have basically double the product, and that made up our middle term. Okay, so let's move on to the next page and I'll give you that shortcut. Okay, so when it comes to squaring binomials, right, again, we're multiplying the same binomial times itself twice, right? Here's a pattern, here's a shortcut that you can apply. Right? So a plus b parentheses squared, we'll take the first term, square it, add 2 times the product of those two terms, and then add the last term squared. When it's the same binomial, or the binomial, the same two terms with a minus sign in between that you're squaring, very similar to the first one, the only difference is that you're subtracting 2 times the product of those two terms. Okay, so now the thing about this shortcut is that you have to be able to use it properly and in the right situation. Right? If you don't understand any of the shortcuts that I've shown you here with these special cases, right, you can always go back to FOIL, go back to the distributive property to try to get your answer. You do not necessarily have to use these shortcuts on homework quizzes and tests. But right, it is pretty efficient if you recognize and know how to do the shortcuts. So let's try a couple of these. So we are noticing that we are squaring a binomial. Same two terms, that minus sign in between. Again, we are squaring a binomial. So according to what we just mentioned here, we're going to take the first term, square it. We're going to subtract 2 times the product of those two terms in the binomial. And that we are going to add that second term squared. Okay, so we got x squared minus 20x plus 100. Right? Again, if we were to actually write this out and multiply it out and use FOIL, right, x minus 10 times x minus 10, right, you will still see that you're going to get the same answer. Okay. But I just think this little shortcut here is a little bit more direct. Next example, again, we are squaring a binomial. According to the shortcut, we're going to take that first term, we're going to square it. We're going to add 2 times the product of those two terms in our original problem. And then we are always going to add that last term squared. Right? Much quicker than going through a full-out FOIL. All right, go ahead and try the last 2 examples, and let's see if this pattern is catching on. Again, we are squaring binomials. So we're going to use that pattern we noticed earlier in the lesson. Squaring the first term, adding or subtracting twice the product of those two terms, and then adding the last term of the binomial squared. All right. And if you have any questions, make sure you let me know.